question, what is a macro? And in the process, I'm going to show you that Lisp and thus Clojure is the most powerful programming language you can have. Normally, I talk about this to people that do not code in Lisp, so this is going to be an interesting new experience. Let's start with a simple piece of code. This is an assert that you can have in any testing library. It's a very simple function that takes a value, true or false. If it's false, it prints an error message. The error message looks more or less like this. That's very straightforward. Now, let's look at that error message. It's not very useful, is it? That's like when John from HR calls and says, computer not works. And it's like, oh, come on, give me more information. Something like this, right? This is slightly more useful, and it's probably what you're used to when you're using testing libraries in most programming languages. And the way you get to an error message like this is by doing something like this. You say, well, now we are going to have a function that compares two things, and if they're equal, it's fine. If they're not, we print an error. The problem is that when doing this, we went from a nice single function, assert, to a more specific one that we cannot use in all the instances. And when we start doing that, what happens is this. We end up having several functions that all do similar things. And then that's not enough, and what happens is this. Right? We start to having more. And then, more. Right? We end up having a lot of them. And you probably forget that half of them exist, and the ones that you need doesn't. Right? This is function as an abstraction mechanism failing us. There's too much in common between all of these things. Before I go on, though, let's go back to the error message. That's the error message that we are normally used to in most testing libraries. That's good. But wouldn't it be better if it was something like this? If I show you this error message, you don't even need to look at the code to know what's wrong and how to fix it. And if I can show you this, I can actually show you this, right? And that is going back to the original single assert function that we can use in all the cases. So now we have a challenge. How do we make that function? We can do something like this. Please don't kill me yet. Actually, so if we try to do something like this, there's some testing libraries that do things like this in some cases. This is something that you cannot do in C. I'm not sure if you can do some black magic to achieve something like this in Java. I think you can't. You could do it in Ruby, and you certainly can do it in Clojure. And the way you do it is by taking that piece of data over there, reading it, turning it into a data structure, and then turning it into code. Now, my choice of words is not random there. I meant data. That there, as a string, is a piece of data. And one of the nice things about Lisp and thus Clojure is that data and code are very similar. We express code in the same data structures that we use. So we can make this better, but making it look like this. So before we have a string that could be malformed, and we wouldn't know that it was malformed until runtime. Now we have data that's at least we know is correctly formed. The compiler will check. It's still not code. That's not code. That's data. We turn it into code when we say evaluate here. That little piece there is what turns it into code. So something very interesting is starting to kind of grow in here. We have a function that takes unevaluated code, and later on at some point it gets evaluated for us, right? Taking unevaluated code and having it evaluated later on, that's a macro. And we can take a small step for a code snippet and a giant leap for mankind and turn that into a macro. Look at the assert. That is beautiful. In there, that thing that comes after the assert is both data and code. And that's why that's one of the memes that we have. We go around saying data is code, code is data, and so on. This is why. So how does this work? How does a macro work? Before I can go there, I need to refresh the rules of quoting and evaluation. This is a number. It evaluates to a number. This is a symbol. What does it evaluate to? Anybody? A function? Yes? This is a quoted symbol. So the quote is like saying, bro, don't evaluate me, right? So it evaluates back to the symbol. It's unevaluated. And the quote can be applied to lists. So in the first instance, that's valid Clojure code, a plus. The second instance is not, because it's a list that starts with a number, and list, to be valid Clojure code, should start with a function. There we get the list. The list can have symbols. The list can have symbols anywhere. And the list can contain nested lists. In all of those cases, I'm at the beginning saying, hey, Clojure, do not evaluate this. Clojure goes, sits on the chair, takes a lazy day, no evaluation happens. There's another type of quote, which we don't use as often, which is the backtick. The backtick does more or less the same, except that there's another special character, which is the unquote. That's like saying, okay, Clojure, get back from your lazy ass and evaluate this. This is very useful because this starts to build a sort of templating language that we can use, and that's very useful for building macros. Actually, I kind of lied here. What actually happens is more or less like this, but let's ignore that and move on. So this is what we had, a macro, a call to the macro. What happens here, let's take it step by step, is that this piece of code, when the macro is called, is going to go into the X. So far, so good. Then when the macro starts to being evaluated, the Clojure sees the backtick and says, okay, I'm not evaluating anymore, fine. So I'm going to return a list that contains a symbol if, not a function, not a verb, not anything. A symbol if that contains another list that contains the symbol not that contains, oh, okay, fine, I have work to do now. I have to evaluate X. What does X evaluate to? Well, it comes from the attribute, right? So it evaluates to that initial thing that we have over there. And as we keep on going, then we have another mention of X. Now, look at that interesting bit. That is saying, evaluate X, but the result, quote it. So the result of evaluating X will not be further evaluated, because a macro will return the code to be evaluated later on. So when we do all this replacement, we end up with something like this. And I like this example of the assertion because it very clearly shows that code is code and code is data at the same time. So when finally Clojure gets around to evaluate all of these, what we get is the nice assertion error that we want with the code. This is very powerful. So to answer the question that started this little journey, a macro is a function that takes unevaluated code and returns code to be evaluated later. That definition is correct, but it's dry and fails to show the implications of this system. One day I was talking to a guy that I just met, and he became a mentor to me. And he was very opinionated about programming languages and technologies. I was also very opinionated about programming language and technologies, but I had the wrong opinions. So we were having this argument. And at some point, between C++, Smalltalk, and Objective-C, and all of these, he said this. Or you can use Lisp, and then you can have any language you want. I didn't know what he meant, but that seemed like there was something in there. Like, I started a journey of learning Lisp to try to make sense of this sentence. So I'm going to try to really quickly take you into this journey in like 5 minutes when it took me like 2 years. Here we have a very simple Clojure program. It adds two numbers together. And outside that door, most people complain that you don't put the plus at the beginning. You put it between the two numbers. We know better, but bear with me. They want this, right? Let's give them this. It's actually not that hard. We can make a macro that does it. This macro is receiving, called infix, is receiving a piece of data. That's not code yet. It's broken code. But what it's going to do is going to try to match for a pattern of, is the first element in the list a number? Is the second a symbol? Is the third a number? If that's the case, swap the first two, and then push it back to Clojure, so Clojure goes and evaluates it. So, and otherwise, just return the expression, so everything else works. So, a good way to know how this is working is to use macroexpand1. Macroexpand1 will take an expression, like this one, and execute one level of macros. The reason why we want to execute only one level is that a lot of Clojure is macros itself. And if you use the macroexpand function, it will evaluate all of those, and the result will be a little bit puzzling. For example, def function in Clojure is a macro. Def macro is a macro. When we run this, we actually get that as a result. And then Clojure goes and runs it. So obviously this is a little toy example, but it shows the power that comes with this ability for us to manipulate the language, to create new languages, new language constructs, to create new languages inside our own language. For example, these days a lot of people are creating DSLs, right? And we just call it programming. This is not something that you can do in many programming languages. I would say it's not something that you can do in any programming language that's not a Lisp. And that's what makes Lisp the most powerful one. Ruby is one of the programming languages that I use the most. So I'm very familiar with it, so I'm going to pick on it. Sorry, Mats. But let's imagine we're going to write a sort of macro that plays with the if statement, that gets an if statement and modifies it, or something like that. An if statement in Ruby looks like this. Pretty self-explanatory, right? But that's not data. That's code. That's text on a file. And we can play with text, and we can have a macro system based on text. And the result is going to be something like the macro system in C, that you only use for simple stuff, because if you do anything complex, you go to hell. And everybody will hate you. So we don't want text. We want to play with data. That's text. What does the data look like? The data looks something like this. This is called the abstract syntax tree that represents that piece of code. So it is completely conceivable to add the features to Ruby that would allow us to capture an evaluated code, have it parsed, have it as data. So have it as something like this. Play with it, modify it, output it again, and have the Ruby interpreter execute it. That is very easy to do. But even after you have that, and programming languages do have that, you won't have a healthy macro environment, because almost nobody is familiar with this data. So almost nobody will be able to play with it. This is a very simple example. Add classes, or add a language like Java or C++, and the abstract syntax tree gets insane. You only play with it if you're writing a compiler. Let's look at the abstract syntax tree for Clojure. You might have heard people say Lisp has no syntax. What they're saying, in fact, is that we have a syntax to express abstract syntax tree, and we are just writing abstract syntax trees whenever we write programs. That's why it's so simple to tap into the data that represents the code. We already know it. We already play with it on a day-to-day basis. You can try now to take Ruby and say, okay, let's push Ruby or any other language a bit further, right? Let's make the abstract syntax tree a little bit cleaner. Let's modify the syntax a little bit so it's closer, so that people are more familiar with it. And by the time you're done, what you did is create another Lisp. Resistance is futile. You've been assimilated. Sorry. That's why you cannot have the power of Lisp without becoming a Lisp. And that's why Lisp is the most powerful language you can have. Thank you.
Are other languages that have macros as powerful as Lisp? Or maybe, I remember that Scala has something. Do you know, have you ever looked into Scala macros?
I did not play with Scala. I know that, for example, Haskell has an extension that I was told is as powerful using Haskell templates. They all suffer from this fact that you stop playing with first-class citizen structures and concepts. I haven't seen any workaround to that problem without becoming a Lisp.
Have you got any advice on when it's good to use a macro, when it's not good to use a macro, and how not to abuse them? Because I've heard some cases where you end up with programs that are just macro and macro and macro and macro and macro, and you don't understand what's actually going on underneath.
Yes, whenever you can avoid macros, you should. So macros should be used as little as possible. Most projects should have only a few macros. I've heard examples, for example, Paul Graham's original startup, they mentioned that they had 25% of code was macros. That seemed to me a little bit insane. You shouldn't measure the usefulness of macros, but how many macros you have, but by how many functions you didn't write by writing a macro. Yes, they should be used careful. It also depends what your project is. If you're writing an application, then you like a web app or something like that's the end result, you're probably not going to have a lot of macros. If you're writing a library that's, for example, a wrapper for SQL or something like that, whether you're very language heavy, you're going to end up with a lot of macros naturally.